Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Today's session topic is problem on cross power spectral density. Okay, in this session we are going to discuss about what is the definition of cross power spectral density and the problem related to the cross power spectral density. Okay, cross power spectral density is applicable whenever you are having two different random process x of t and y of t whenever you are using whenever you are using two different random process. The definition tells that Sxy of omega, we are having two definitions. One of the definition is Sxy of omega is equal to integral minus infinity to infinity Rxy of tau e power minus j omega tau d tau. Okay, this is one of the definition. This definition tells that cross correlation function and cross power spectral density form a Fourier transform pair. Okay, it may be either x of t and y of t or two, and next you can also calculate for y of t and x of t, that is denoted as s of x y x of omega is equal to integral minus infinity to infinity r yx of tau e power minus j omega tau d tau. Okay, here we are taking the input as cross correlation function of x of t and y of t, or cross correlation function of y of t and x of t. Okay, the resultant output we are going to solve the cross power spectral density of x of t and y of t by using these two expressions. Okay, you can have the inverse Fourier transform for the given expression, that is Rxy of tau, which is equal to 1 by 2 pi integral minus infinity to infinity Sxy of omega e power j omega tau d omega. This is for x of t and y of t. If I want to solve for y of t and x of t, Ryx of tau equal to 1 by 2 pi integral minus infinity to infinity Syx of omega e power j omega tau d omega. Okay, this is the definition of cross correlation, cross power spectral density. Okay, the relation between both. Okay, this is one of the definition. Next, second definition you are having. Second definition tells that Sxy of omega is equal to limit t tends to infinity expectation of x t conjugate of omega modulus yt of omega by 2t. Okay, this is the definition, second definition of cross power spectral density, cross power spectral density or cross density spectrum. Okay, you can call in any manner, where t is the time duration. Okay, and here two signals x of t and y of t. Okay, here you are having expectation of modulus. Okay, this is you are having modulus of that. You can have the one more if you are having y of t and x of t, then Syx of omega is equal to limit t tends to infinity expectation of mod of xt of omega into yt conjugate of omega. Here also you are having the modulus for both. Okay, this is a product we are having xt of omega into yt conjugate of omega by 2t. Then what is xt of omega? Xt of omega is equal to limits minus t to t x of t e power minus j omega t dt. Okay, here the definition. Next, yt of omega is equal to integral minus t to t y of t e power minus j omega t dt. Then conjugate, if you are having the conjugate of that, okay, if you are having xt star of omega, then what you are having minus t to t, if you are applying conjugate of t, x of t e power j omega t dt. Okay, then if you are having yt of conjugate, yt star of omega, if you are having conjugate, integral minus t to t y of t e power j omega t d omega. Okay, these are the two formulas we have to use. Okay, based upon the problem, we can use any one formula. You will get the same result of the cross power spectral density. Okay. Now we'll solve the problem related to this. Okay, the given the cross correlation function is given. Okay, directly you can take the Fourier transform of that. Okay, then what you are having to solve the cross power spectral density is xy of omega, or omega means what? Angular frequency, which is equal to 2 pi into f, or in terms of frequency, both are okay, same terminology you are going to get. Okay, then what you have to use the formula s xy of omega is equal to integral minus infinity r xy of tau, okay, e power minus j omega tau theta. Okay, before solving the problem, here you are having mod. Okay, mod x, we are having the formula modulus mod x equal to x for x greater than or equal to 0, which is equal to minus x for x less than 0. Okay, the first you have to solve this one. Okay, your mod t, you have to substitute the change the interval from minus infinity to infinity. Okay, then you have to use the formula. You are having the, okay, minus infinity infinity. Okay, if you are having the minus infinity to 0, minus infinity to 0, you have to use the formula 2 e power tau, you are going to get minus of minus, okay, your mod tau, okay, minus tau, then you have to substitute that whatever you are having, e power minus j omega tau, now plus 0 to infinity 2 into e power minus tau, e power minus j omega tau deta. Okay, you have to split this one because you are having the modulus value. Okay, then you are going to get the resultant of that. Okay, the solution we have solved here. Okay, you are having the cross power spectral density is the Fourier transform of cross correlation function, just now I discussed. Okay, sxy of omega or xxy of f, integral minus infinity r xy of tau e power minus j omega tau, or omega is equal to 2 pi f into d tau. Okay, substitute the whatever the given in the question. Okay, 2 into e exponential to the power of minus mod tau, you substitute that. Okay, now you split that. Okay, split the integral mod tau greater than or equal to 0, tau less than 0, 0 to infinity you will get e power minus mod tau, minus infinity to 0 you will get e power tau. Okay, then you substitute that. Okay, you can use the substitution method. Here you use it as u equal tau, or 0 to infinity e power minus tau. Okay, then 0 to infinity, okay, whenever you are having exponential to the powers, you can sum the terms. Okay, 1 plus j into e power 2 pi. Okay, e power minus t. Okay, e power minus at term, that is 1 by j omega. Okay, j omega, here whatever the term you are having, you are going to get 1 by s plus a, or okay, we are having the term 1 by 1 plus of this term we are going to get. Now similarly, you will solve the second term. Again, you can have the exponential terms. Again, you are having powers, you can add tau minus of 1 minus, if you take 1 minus j 2 pi omega tau, then you are going to get 1 by 1 minus j into j 2 pi f. Okay, you are having got the two terms. You substitute the first term in the first relation, second term in the second relation. Okay, first term in the first relation and second term in the second relation. Then you are going to get the resultant of both the terms. Okay, 2xxy of omega is equal to 2 into 1 by j 2 pi f by 1 by j minus j 2 pi f. Do the LCM for both, cross multiply on that. Then what you are going to get, this term and this term will get cancelled. Will get 2. 2 into 2, 4. 4 by, you, what is that? This is in the form of a plus b into a minus b, a square minus b square. Okay, when you do the a square minus b square, you are going to get 1 minus, okay, minus j 2 pi f whole square. Okay, you know that j square is equal to minus 1. Okay, take outside the j square equal to minus 1, you will get 1 plus 2 pi f whole square. Okay, that term only you are having this. This is the way you have to solve the problem. Okay, this is the way you have to solve the problem related to this. Now next, okay, same problem you can also solve by using the second method. Okay, same problem you can solve by using second method, but here they given directly the cross correlation function. Okay, instead of that, if they given in the question that if you are having x of t equal to a cos omega naught t plus phi. and y of t equal to b sine omega naught t plus y. They give the question in this way. Then how to solve the cross PSD? Cross PSD you can solve by using the either first method. First method is the somewhat the easiest approach for less complexity you are having. Then what you have to do? You have to first solve the autocorrelation of the given random process. Now next you have to solve the autocorrelation of the given random process. Then you have to solve the cross correlation of the given random process. Okay, then you have to substitute in the relation xy of omega equal to integral minus infinity infinity rxy e power minus j omega tau deta. Then you will get the answer related to this. Or otherwise you have to solve the, otherwise what you have to take, you have to take the, okay, you have to take xt of omega, you have to solve xt of omega, you have to solve by taking the interval of this minus t to t x of t, okay, e power minus j omega t theta. Now next you have to solve this one yt of omega for the interval minus t to t, okay, y of t e power minus j omega t dt. Okay, here both the takes in, before that you are having 1 by 2t. Okay, okay, here have, okay, this one we have to solve for x of t and xt of omega and yt of omega. After solving xt of omega, next you have to apply the conjugate xt conjugate of omega, yt of omega. Then you have to follow the, what is that, expectation of this. Okay, now before solving the expectation, first you check the absolute value and divide by time 2t, and then what you are having the second definition, limit t tends to infinity 1 by 2t expectation of mod xt star of omega yt of omega by 2t. Okay, modulus. Okay, you are having the modulus for both. Okay, if you are solving this, then you are going to get cross PSD for x of t and y of t. This is the second approach. First approach is somewhat easier manner to solve, the complexity is less. Okay, this is the second approach. In this way also you can solve the problem. If either way, any one of the way, you will get the same result. Okay, in this session we have discussed the problems related to cross PSD, and we have discussed the definition and the significance of using the cross power spectral density.